Assalamu alaikum. Hello viewers. Today I'm going to show you some more problems for sequence and arithmetic and geometric progression from this chapter. First I will show you a important proof of s infinity is equal to a divided by 1 minus r. From this expression, sum of n terms of series, which is a times 1 minus rn divided by 1 minus r. We know that for this sequence ar square and ar cube, sum of n terms is this expression. We can write this expression through this way, which is a divided by 1 minus r minus ar to the power n divided by 1 minus r. So for this expression, three cases will arise depending on the value of r. Like for case 1, when value of r lies between minus 1 to 1, we know that r to the power n tends to 0 as n tends to infinity. That means if we increase the value of n to the infinity, the r to the power n will be 0, and then ar to the power n divided by 1 minus r will also tend to 0. Thus Sn tends to 1 minus 1 divided by 1 minus r as n tends to infinity. Similarly for case 2, when r greater than 1, r to the power n tends to infinity as n tends to infinity. Hence ar to the power n divided by 1 minus r tends to minus infinity when a less than 0, and this expression will tends to infinity when a greater than 0. That means this expression tends to minus infinity when a is less than 0, and it tends to a positive infinity when a is greater than 0. Thus the sum to infinity cannot be found. If we see for case 2, notice that when r less than minus 1, what will happen? Before that we analyze the case when r is greater than 1, but what will happen when r is less than minus 1, right? So and then if n is even, rn tends to infinity as n tends to infinity, and n is odd, rn will be minus infinity as n tends to infinity. That means this expression will alternate between increasing positive value and decreasing negative value. It does not have a definite value, and sum to infinity cannot be found. But when r is equal to minus 1, the geometric progression becomes like this: a minus a minus a. That means this expression alternates between the value of a and 0. Thus sum to infinity cannot be found either. But what will happen when r is 1? The progression becomes a, and sum to infinity, sum of n terms will be infinity as n will tends to infinity. Thus sum to infinity cannot be found. So sum to infinity will be 1 a divided by 1 minus r exists only r, the value of r will be lies between minus 1 to 1. So here basically I want to clear you the concept. Why is sum of infinity is a divided by 1 minus r, and why the value of r lies between minus 1 to 1. This is the concept here for the value of r. Now I am going to show you some problems through this formula. Here I have given we are given a series here 1 plus 1 by x, 1 by x square and 1 by x cube, and where the value of x is less than 1, absolute of x is less than 1. So here first term is 1, for a is 1, and common ratio is 1 by x. If we notice that if absolute value of x is less than 1, if we reverse it, 1 by x must be greater than 1, according to the characteristics of, according to the rule of inequality, right? So 1 by x, if 1 by x is less than 1, that means common ratio is greater than 1. If x is less than 1, that means 1 by x is greater than 1, which means common ratio is greater than 1. So we know that if common ratio is greater than 1, the series is not convergent, according to the rule of convergence and divergence. And similarly, for this series, first term is 1, common ratio is less than 1, which is x. Why x is less than 1? Because we are given that absolute value of x is less than 1, so it will be, the series is convergent. And for the third series, 3 plus x plus 12 plus 24, first term is 3, common ratio is 2, which is greater than 1, and the series is not convergent. Why? Because the common ratio is greater than 1. Now we are going to see some more problems from 3. Number 3, here I am going to see you some problems where we will find sum to infinity from the series. Here first term is 81 and common ratio is minus 1 by 3. So sum to infinity will be a divided by a 1 minus r, and which is 6, and 3 by 3 out of 4. Similarly, for this series sum to infinity, here we can see that we can write this series by two series, right? a, a square plus a cube, and b plus b square and plus b cube. From the first part we find a sum to infinity is a divided by 1 minus a. For the second part similarly we get b divided by 1 minus b, and for the whole series we get sum to infinity is a divided by 1 minus a plus b divided by 1 minus b. This is our answer. Similarly, for this series, first term is 9.6, common ratio is 3 by 4, and then sum to infinity will be a divided by 1 minus r, and if we put the value of r we get the sum to infinity is 38.4. And now here is a critical problem here. First term is root 2 by root 2 plus 1 divided by root 2 minus 1, and common ratio, we have to do a little calculation here, uh, and we get the common ratio is 1 by root 2 times root 2 plus 1, and sum to infinity will be a divided by 1 minus r. The value of a is value of a is this one which we found before, and common ratio is 1 by 2 plus root 2. And then if we see after calculation we get that a sum to infinity will be 4 plus 3 root 2. Here we what basically what we do here, we always know that we can remain we can keep root over expression in the denominator section. So during the calculation we try to remove a square root term from the denominator section. Here we see that if we multiply, if we keep it in multiply from, we find root 2 plus 2 plus root 2 divided by root 2 minus 1, and then we multiply in both numerator and denominator by root 2 plus 1, and then in the denominator section we apply a square minus b square formula, and the numerator will get 4 plus 3 root 2, and this is our answer. So that's this are my problems for today. I hope this lecture will help you. Please support me, and if you have any problems from this section, you can write this in the comment box, and please subscribe my channel again. I hope you all the best. Thank you everyone.